For our last section today, we're going to simplify higher radical expressions. And then the directions say we want to write the following in simplified radical form and assume that the variable represents a positive real number. So let's do example 1. Example 1, we want to simplify the cube root of 54x to the fourth. So the first thing is we want to separate the coefficient and the variable. So how do I do that? I'm going to use the multiplication property. So this is equal to the cube root of 54 times the cube root of x to the fourth. Again, I'm going to focus on this one first, and then we'll go on to the second part. So now for the cube root of 54, I'm going to look at the column with the perfect cubes because n is equal to 3. And I'm going to find the first number that is less than 54, which is 27. Right? And then from a previous video, we have determined that 27 goes into 54 2 times. So I can rewrite the cube root of 54 as 27 times 2. Right? And then we're going to bring this down. So and then we're going to use the multiplication property again. So this becomes the cube root of 27 times the cube root of 2. And then bring this down again. So the cube root of 27, that is 3, because 3 cubed is 27. And then for the cube root of 2, this is as simplified as it can get, because the smallest perfect cube is 8. And so we know for a fact that this is as simplified as it can get. Right. So now let's talk about the cube root of x to the fourth. So again, I'm going to reiterate the first condition is that the radicand has no factor raised to a power greater than or equal to the index. So what is our index? Our index is 3. So so to be simplified, the power of our factor can either be 0, 1, or 2. In this case, that's not the case. Why? Because our power is equal to 4. Right. So now I have to think, what is the first perfect power that this is? So I guess our question is, how many times can 3 go into 4? In this case, it's 1. So then x to the fourth, this gets split into x cubed times x. All right. Again, we're going to use the multiplication property. This becomes the cube root of x cubed times the cube root of x. Right. And then what is the cube root of x cubed? That is x. Right? Because x cubed is equal to x cubed. So 3 and then cube root. This becomes x. And then for the cube root of x, in this case the power is 1. And 1 is definitely less than 3. So then we know that the cube root of x is as simple as it can get. This is not our answer, but we're almost done. So now we want to combine the terms that don't have the radical and the terms that do have radicals. So we can combine 3 and x. So it becomes 3x. And then for the cube root of 2, we have the cube root of 2 times the cube root of x. I'm going to use the multiplication property again, but instead of separating them, we're going to combine them together. So then this becomes 3x cube root of 2x. And this is our answer. Now for our final example of the day. So our example, we want to find the fifth root of 32y to the 14th. again, we want to separate the coefficient and its variable. So this becomes the 5th root of 32 times the 5th root of y to the 14th. Right? So now let's figure out what's the 5th root of 32. So I'm going to go where n is 5, and I'm going to find the first number that is equal to or less than 32. And then, lucky for us, so the best case scenario, 32 is equal to 32, so we don't have to split anything. We already know that the 5th root of 32 is 2, because 2 to the 5th power is equal to 32. So now let's look at the second part, so the 5th root of y to the 14th. So first, what is our index? Our index is 5. So we want the power. We know that it's the variable is, or the factor is most simplified if its power is 0, 1, 2, or 4. Right? 14 is not equal to any of those. So 14 is definitely bigger than 5, so we have to simplify this. Right? So one way to do this, so you can also think like 14 divided by 5, so, or 14 divided by 5, it can go in there twice perfectly, and then there's a remainder of 4. You can do that, and so you can split it up as y to the 10th times y to the 4th, right? But if that confuses you, that's completely fine. So let me try to explain it another way. So we want to find the first number, the first perfect power that can go into, or sorry guys. We want to find the first perfect power that can divide into 5 evenly. So I'm going to look at 14. So then we can just go down one power at a time. So then we can look at y to the 13th times y. But then I ask myself, 13 divided by 5, that does not give me a whole number. So I'm going to go down into y to the 12th, and we're going to bring this power up. As you can see, this is not changing, because this is still y to the 14th. This is still y to the 14th. So I'm just moving the powers over, but this is still the exact same as this. So now I'm going to ask myself, 12 divided by 5, does that give me a whole number? The answer is no. So then I'm going to go down, and I'm going to take a power away. Right? And so then I'm going to ask myself again, 11 divided by 5, does that give me a whole number? No, it doesn't. So then this doesn't work as well. Then I'll go to y to the 10th, and then add to this one, so it's y to the 4th. These are still y to the 14th. Right? And then I'm going to ask myself, 10 divided by 5, does that give me a whole number? And the answer is yes, because 10 divided by 5 is 2. So that's how we know we can rewrite this as the 5th root of y to the 10th times y to the 4th. Right? So then let's use the multiplication property to rewrite this. So this becomes the 5th root of y to the 10th times the 5th root of y to the 4th. Right? If you want, like if you understand, so you can do y to the 10th divided, so 10 divided by 5, you can just tell me this is y squared. So if it still kind of confuses you how to get that, let's show more steps. So how can I rewrite the 5th root of y to the 10th? I can rewrite this as y to the 10th to the 1/5. Right? And then now we're going to use the power property, power over power. So 10 times 1/5, that is 10 over 5. 10 over 5 is 2. So this becomes 2y squared. And then when I look at the 5th root of y to the 4th, when I look at the 5th root of y to the 4th, the index is 5 and the exponent is 4. So it's one of the options that I can have. So therefore, the 5th root of y to the 4th is as simple as possible. In this example, there's no number to combine it with because 32 was an even fifth power or fifth root. So this is our solution.